This next video is of the last transformation feature, and then we're going to put them all together, which is the constant d. So the d on the end of the equation is not in a bracket with x, so it's affecting y. And if d is greater than 0, then your graph is going to move up. And if d is less than 0, then your graph is going to move down. So if you look here, I've got a cos x example. The gray graph is y equals cos x. The green graph is y equals cos x plus 0.5. What happened? Well, the graph just got literally moved up 0.5. If you do y equals cos x minus 2, the graph literally gets moved down 2. Same thing with sin x. Plus 3.5, move the whole graph up 3.5, and minus 4, move the whole graph down 4. Now what I want to look at is what this affects. For these examples, so looking at these graphs, did the amplitude change? So the amplitude is the absolute distance from the center line to the max or the min. So if I was to draw, where's the center of this graph? I would draw it here, or this one, I would draw it here. The distance here is your amplitude. It's still 1. So no, it doesn't affect amplitude. Does it affect the period? Well, no. I still have a cycle between 0 and 2 pi. I still have a cycle between 0 and 2 pi. So nope. Domain? No, nothing does. What about range? Definitely. In fact, if we look at the range of some of these graphs, so let's look at this one here, y equals sin x minus 4. It's going up to 3, negative 3, and it's going down to negative 5. So the range of this graph is from negative 5 to negative 3. What about this graph up here? Well, you've kind of got the center line at 3.5, and then we go up 1, so it's going as high as 4.5, and it's going as low as 2.5. So when the amplitude is 1, and you've got your center line moved up 3.5, then you're going from there. So this one has an amplitude or a range of 2.5 up to 4.5. So it definitely affects the range, and it definitely affects the center line, and it definitely affects the x-intercepts. But what I want to look at is how it affects it. So most importantly, d is the only transformation that affects your center line, right? So your a value affected your range as well, but your center line is the only one that's affected by d. D is the only one that affects the center line. Anyway, what I want to look at is the center line is whatever your d value is. So, your center line is normally at y equals 0. So if you have it at 3.5, if you up 3.5, now your center line's at 3.5. So to find your range, what you're always going to want to do, and I should have made a spot for this, but to find your range, what it's always going to be is your center line, which is your d value, minus a, up to your center line plus a. So if you look at this graph here, you had a center line at 3.5, so it went down 1 to 2.5, and it went up 1 to 4.5. So let's look at a graph over here. Let's look at the minus 2. So when it's moved down 2, that center line is at y equals negative 2, and your range is going to go up 1 from there and down 1 from there. So your range is going to be negative 3 to negative 1. And that's the easiest way to figure it out from your equation. All right, so now let's look at graphing that transformation. So we're going to graph y equals sine x minus 4. We know that this minus 4 is going to move my entire graph down 4. Now, let's fill out all this stuff before we actually graph it. Scale. What did we use? 1, 2, 3, 4, 5, 6, 7, 8. So the scale of this graph is pi by 8. The amplitude is the absolute value of a. A is 1. The period, the b is 1, so it's 2 pi divided by 1, which is just 2 pi, which means my key points will happen every pi by 2, which from a grid line perspective is 4 grid lines, right? Halfway to pi, or you can think of it as doing pi by 2 divided by pi by 8 leaves you with 4 grid lines. There is no phase shift, so we don't have to worry about that. And my vertical displacement is down 4. Domain is always going to be negative infinity to infinity. Now let's figure out the range before we get started. Okay, you don't have to do this, but your range is a minus d. Oh, did I write that as a minus d? No, good, I did it right. It should have been d minus a. Okay, is your center line minus your amplitude up to your center line plus your amplitude. So for our graph, it's going to be negative 4 minus 1 up to negative 4 plus 1. So I'm predicting that my range is going to be -5 to -3. And again, I'm doing this without graphing it, which I don't have to do, but I just want to show you that you can. So we could figure out range after we've graphed it, and that's okay. But how are we going to graph this? Well, let's look at a sin x graph. Sin x graph usually starts at 0, 0. This is going to be moved down 4. So I'm going to now start at 0, -4. Now we said that every 4 grid lines we're going to have a key point. So 1, 2, 3, 4 grid lines. I'm going to go up how much? Well, just 1. So it's just here. And then in 4 grid lines, I'm going to go back down to -4. In 4 grid lines, 1, 2, 3, 4, I'm going to go down to -5. In 4 grid lines, 1, 2, 3, 4, I'm going to go back up to -4. And then I can't fit any more, so let's go the other way. 1, 2, 3, 4, down to -5. 1, 2, 3, 4, back up to 0. And then I'm going to connect my dots. So this is my y equals sin x graph moved down 4. And what did it affect? Well, it affected my range, right? That's the big thing. So now you can do part 2, worksheet numbers 5 to 8.